the module 2, okay, the assembly language 2 assembly language programming structure. So I hope you guys have already checked this one. Okay. So what's this assembly language programming? Okay. So first, this is statements, or these are just statements that becomes executable when a program is assembled. From the word itself, assembly language, or once they are assembled, or those statements are assembled together, then it can work as a simple program. So this is a line oriented with one statement allowed per line. So we have three classes of statements right here. We have instruction, which is saying that this is a machine instruction in symbolic form. Second one is directives, wherein these are statements gives directions to the assembler. And then we have the pseudo operations. This is a special type of directives that gives the assembler information about data alignment, block and segment definition, and base register assignment. Okay. Well, you can just simply focus on directives and pseudo operations. Okay. So directives and pseudo operations is just an assembly program that is consists of 4 blocks or 4 parts, which is called segment directives. And these are the model, stack, data, and code. And then each block is represented by the name model, stack, data, and then code itself after the dat. So this is the first one, the dat model. Second one, the dat stack. The third one is that data, and then the dat code. You can include this one as part, but it's not included as the 4 blocks. But this one is needed, of course. Okay, the end message, but it's not starting with that. So in here we have the dat model small, and then the dat stack 100H. So you guys don't need to worry about anything with this one anymore. So whatever you guys are seeing here, it's already it. Okay, you do not change the small into compact, medium, or huge, or any kind of size. Okay, so all throughout of this course, we're going to use small. So small is already enough to run all of our programs, since all of the programs that will be done under this course is short lines of codes. Okay, so hindi naman siya ganun kalalaki. And then second, we have that stack 100H. So this one identifies the area of the program holding the runtime stack, setting its size pointers. So 100H in hexa, or this 100, okay. But this one is in the form of a hex decimal. So again, for this one, you also don't need to change this 100 into any other values. So in other words, the dat model and then the dat stack is already as it is. Okay, so just use small and 100H all throughout of this course. So the changes will happen under, of course, that data and then that code. So that data can be used to define variables and constants, and then without that code, this one holds the executable instructions. So for now, just you guys don't need to worry about what will happen under this certain code. But yeah, here is the structure of a simple assembly language. Saying let's see, simple hello world on a console. Okay, so let's start with the data defining assembly directives. Oops, I missed this one. Again, this is just a note that for all the practice exercises, use model small and then stack 100 each. Okay, very, very important. So for the data defining assembly directives, this is the same as defining or declaring a variable. So all directives must be in that data block. So we have 5 ways to define a data. So we have the DB for byte, DW for word, DD for double word, DQ for quad word, and then DT for still quad word, but this one is now like a bigger size. Okay, so you guys will know later on what's the difference between this DT and then DQ. Anyway, for the DB, DW, and DD, so they are very straightforward. It's would be easier if we have the notepad right here. So those are our ways of defining a data. Again, word, DB. So for the defined byte, so this one would contain 1 byte or more. Okay. But in other words, it's just containing byte. Okay. If it's more than that, the next one is already word, wherein this one can contain where is it, one or more double bytes. So double byte is one word. Maganda siguro pag may limitation. Let's just say that this one is 8-bit. And this one can accommodate 16-bit. And then for the DD is double word. Define word double byte. This is double word. So from 16, just double this one, one word into double word. But of course, we'll now have a maximum of 32-bit. While on DQ, of course, it's quad word. We're just going to, have 4 times of that word. So from 32, we now have 64. 16 times 4 is 64-bit. While the DP is also called the, quad word, but how are we going to differentiate their names? Anyway, let's just say quad word. When we see DP, this one can contain up to 80 bit. So they come with sizes. So DB is for 8-bit. Okay, that's the maximum that it can store. And DW is 16, DB is 32-bit, DQ is 64, and then DP is 80 bits. This is the highest, okay, that we can store into a certain cell or location. Okay. Now we have some examples here wherein DB or defined byte is allocate initialize one or more bytes of data. So we have the variable name and then the defining function, which is in DB form, and then the initial value, and then up to how many values you want. Okay, you can put in there. So let's say this is your variable name mem db, and then we have let's say 3 initial values right here, wherein all of them are of course in hexadecimal. So 35h, 0fh, and then 60h. Okay, so if you're going to put this one into a, let's see, memory or register, here's the first one, 35h, 0fh, and then 6dh. Okay. And if we have double defined word, okay, not double word, okay. So this one now is now 6, it can accommodate up to 16-bit. Okay. So we could now have 1, 2, 3, 4. Okay, 4 characters instead of 2 only, because it's now like double byte of this one. Okay. So if we are going to put this one into a memory, still this memory cell can only accommodate up to 8-bit. Okay. So going back to the first one. So you guys will see here that, for the EX, BX, EX, DX, this one can accommodate 8-bit and then 8-bit only. Okay, or let's just say a maximum of 16 bits, since it says here that 1 or more bytes, but in reality it's just up to 2 bytes. Okay. So if we are going to convert this hexadecimal to binary, where's that one? Let's see, 35h. 35. Okay, so we have 8-bit, okay, maximum. Okay, so that is the conversion for the 35h, and then for the 0h, same. We also have 8-bit, 4-bit only. Okay, so 1, 2, 3, and then 4. Okay, but of course, it's considered as one cell. You're going to include the 0. Okay, we have 0, 0, 0, 0 right here, and then F is the 1, 1, 1, 1. So do you guys have any idea how did we come up this 1, 1, 1? Alam nyo? Don't tell me you guys don't know how to convert, let's see, decimal to binary or binary to hexadecimal yet. Okay, let me call someone. Mr. Ferreras, do you know how did we come up with this 1, 1, 1, 1? from this 0F hexadecimal into binary?
Alam sir, pero di ko natanda rin. I-refresh lang po.
Yeah, okay, so it's actually 842. F is actually equal to 15. Okay, maybe I need to refresh you guys. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting from 10, okay, it's already A, B, C, D, E, F. Okay. So 1 to 9 is as it is, it's 1 to 9, but this one is 10 already. 11, 12, this is 13, and this is 14, and this is 15. Now these are, let's see, the decimal values and then up to the hexadecimal values. So if we're going to convert this F into binary, okay, so say we have 8 bits, okay. The first value right here, kasi, muna tayo. The first value right here on the right side has a value of 1, followed by this one is 2, followed by the third one is 4, followed by 8. Okay, so 1, 2, 4, 8. Okay, so we have here 1, 1, 1, 1 because we have to activate the 1, 2, 4, 8 to come up with the value of 15. So 8 plus 4 is 12, plus 2 is 14, and then plus 1 is 15. And then it doesn't show the 0 right here anymore because, of course, this is just the 0 value. That is why I'll remove this 1 and we'll just still simply give us this 1, 1, 1. Okay, but if we have 1 right here, let's say 1F, then we have to activate this 1. So it will give us a value of 0, 0, 1, and then 8, 4, 2, 1. Well, anyway, just maybe you just need to refresh, okay, your knowledge regarding the binary system. So that's how we've come up with this 35H, 0H, and then 60H. And then again, our cells or memory location can only store 1 byte. Okay, 1 byte is equal to 8 bit. 1 byte is equal to 8 bit. Okay, so bit is this one by one. So in here we have a total of 8 bit. So even though we have already defined this one into a word, wherein word is equal to 1 byte, my bad, 1 word is equal to 2 bytes. Okay, so we have a total of 16 bit now from here. So even though we have already here a double word or a 16-bit individuals, we still have to save this one by 1 byte. Okay, so you're going to save this one, let's say 0F right here, and then 35 right here, 45 right here, and then 60 right here. Okay, so we cannot store a total of, let's say, 16-bit in one cell. That is because we can only store up to 8-bit because of this, storing of memory, something like here. These registers right here. So 8-bit, 8-bit only. All right. So this is just a double word wherein, of course, we can now have 0F35H. And if we're going to convert that one into 0 F35H, it will give you a total of 16 bit in total. So the same with 456D H. Okay, so H is just an indicator that saying that this one is in hexadecimal form. Okay, while in the defined double word, well, of course, this double this defined word right here from 4 characters into 8 characters. We now have 1, 2, 3, 4, 5, 6, 7, 8. Then again, however, even though we already have this one defined into a double word, if we are going to store that one into a memory, it can only store this one by 1 byte. So 35, 0F, 60, and then 45. So we are now similar with this double word. Okay. And then for DQ, wherein of course from 32-bit will give us a maximum bit of 64-bit. So from 8 characters, this one now has a total of 16 characters. And again, regardless of how many characters we have in here, we can only store 1 byte each cell. So we can have this one upon storing those characters or hexadecimal values. Okay, so 35, 0f, 60, 45, etc., etc. While on the other hand, so this is the largest that we can store. Let's see, define quad word. So this is an example, memdp. So this is an uninitialized. Okay, so we can actually put a question mark. We are already taking a certain uh, storage, but we don't know the value yet. Okay, so it's like that's the meaning of uninitialized value. Okay, so these are initialized value. You already know the values of what we are going to store in this memory or register. But if it's question mark, then you can just simply say that they are 00 for now until already given has or until it was already overridden by a certain value. Okay, pag may dumating ng bagong value or once it's over written by a certain let's say variable, and that is the only time that could have a uh, real value. Okay, so that's it for DD. Okay, so from 64-bit, just add 8, 16, just add 2-bit, 2 more bit. Tama ba? 74 plus 8. Yan nadagdag dito. I just got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's an additional 2 bytes. Okay, for the DP. And then we have here again the uninitialized value, wherein this one indicates a value that assembler allocates but does not initialize, so it can be used alone or with dupe or duplicate. So we have here the simplest example, wherein we have a variable mem or label mem. So this is a double word. So meaning if it's double word, if it's just one, then it would get at least 2 bytes. Okay, so let's see the first 2 byte. It's db. How about dw is double word, defined word, sorry. And then db is defined byte. So defined byte is just 1 byte. So we have 3. So it will going we're going to get 3 cells right here. And then for the db, so we have 20. Okay, 20 cells, and then you're going to duplicate this one, which is has an unknown value. Okay, so initially, of course, if it's an unknown value, it will not duplicate this 20 characters yet. So initially, it will accommodate 20 cells. But if you put here 1, okay, you're going to duplicate this one by 1. Okay, so 20 times 2 is like going to have 40 cells right here. Okay, anyway, so maybe you don't get what is this dupe yet, since we haven't discussed this dupe. Okay, let's now discuss that dupe or duplicate. So again, this one initialize several locations and to assign values to this location. So also used to store repeated patterns into larger variables and buffers. So we have 2 examples right here, wherein we have this variable name ARR, double word, 5 dupe, and then 0. So in here, we have a double word, okay, meaning we are going to accommodate at least 2 bytes, okay, for each of this cell right here. So are you guys getting the idea of this double word or double byte? Nakuha nyo ba kung bakit and why we're having a 10 cells right here? Okay, so this one allocates 5 words and initializes all 5 words with 0. Again, 1 word is equal to 2 bytes, right? So in other words, 1 word is equal to 2 bytes. Okay, so that is why we have 10 cells right here, because we need 10 bytes for these 5 words. Because then again, 1 word is equal to 2 bytes. So were you guys able to follow on how did we get these 10 cells of ARR right here? Okay, that's good. Now for the double byte, since double byte, why do I keep on saying double byte? PB, defined byte. Defined byte is just 1 byte. Okay. So meaning we're going to duplicate this one, okay, 5 times, or in 5 set. So we have 20H for the first byte, and then 40H for the second byte. So we have the first set, okay, that is the first duplicate, second duplicate, third, and then fourth, and then fifth duplicate. Okay, so if we have three, let's see, values, right? Let's say 20H, 40H, and then 60H. Then from 5, it will become still set 5, but we'll have a total of 15 cells in total. Okay. So anyway, so 20H is already getting the first byte, and then 40H is already getting the second byte. So a total of 10 cells in total. So were you guys able to follow on how did we come up with this, values in these registers or cells for this defined byte? All right, so next is the PTR or pointer. So this one defines the size of operand or distance a reference have. It is used to override the default type for one instruction. So in here, you're simply passing the value of this variable into another variable. Okay, so we have this one as an example. So assume value is a word, wherein of course a word is 2 bytes, and then we have 4435 each for this one word, and then we have this code move value. So it will give you an error because again, this right here, where is that one? Okay, can only accommodate up to 8 bits or 1 byte only. Wherein you're going, in here, you're trying to transfer a one word into a 1 byte, okay, or a 2 bytes into a 1 byte, okay. So you cannot do that one, okay. You can only move a certain value if the location is larger from the original size that you're going to transfer, okay. So of course you cannot fit 2 byte into 1 byte. Okay? So to make this one work, you can just simply use pointer, okay, wherein it's you're still moving that value into that but you're only getting the most significant bit. So when we say most significant bit, you're only getting the left most significant bit is the left side. Bit furthest to left. Yeah, okay. So it is the most left side data, okay, or character. So in here, as an example, move AH by PTR value, it will give you a result of 35H. So even though you are trying to store this 4435H, okay, on the most left side, wait, tama ba? My bad. Okay, this is not the most significant bit. This is the least significant bit. Okay, so for the first one, it's the least significant bit. If it's the most significant bit, it is the second one. So it's the other way around. So for the first one, it's the least significant bit, wherein you're getting the first 2 characters on the right side. Okay, so we have here the result of 35 each. And then the only difference between these two is that this one has a +1. Okay, so from let's see, a least significant bit, maybe just adjust 1 byte. Okay, and then you are now getting the next byte, which is the 44 H, or the 44 H. Okay, and then if maybe, okay, if you can try to make this one work on the M886 value +2, meaning you are moving 2 bytes from the least significant bit and then getting the byte after those 2 bytes. Okay, so are we clear so far regarding with this one? Are you guys getting the idea of this value and then value +1, or maybe value +2? What about the others? So I hope we're really clear with this one. If you guys need more example, we can have one example for this one. Pero mukhang wala namang question. Anyway, so the last one pa na ba to? Okay, second to the last is the offset. So this one is used to load the offset of memory location to a pointer register. Okay, so in here it's just saying that before we can move something else, so it will also accommodate a certain memory. Okay, so for example, that data nam DW 0F012H, we have this one wherein we have moved SI offset num1. So the offset is the distance of num1 from the start of data segment of num1 is loaded to SI, and then SI will be used to access 0F12H. So in order for you to transfer this one, or let's say access this one, of course you have to store this one first. Okay, so let's say this is where you're going to start store that one, starting from the start up to the 005. Why up to 005? Because it will save these characters one by one on this cell. So 0, F, 0, 1, and then 2. Okay, and then if you're going to access that one or save that one into, let's say, num1, then of course it will now accommodate another 5 cells. Starting here, we have 0, F, 0, 1, and then 2. Okay, so yeah. So this is an abstract illustration of the example as I will now have the value of 5. Okay, because that's the counts of characters that it accommodated according from this example value. So if you have 4, then it will have a value of 4. If you have 3, then it will have a value of 3. Okay. And then EQU is as simple as equate. Okay, this one is used to assign a constant or a variable or an expression to a variable. So equal or equate is used for numeric values only. Okay, let's see, count is EQU 10. Okay, this one now has a value of 10. Then equated symbols are not variables. Okay, so this is not a variable, and this is just, you could consider this one as a symbol maybe. Okay, so this element now has a value of 5. And then EQQ expressions are evaluated where use or equal expressions are evaluated where defined. So for example, my string EQU and then hello. So this one now has a value of string hello. Okay, or you can use the symbol itself. Okay, this equal sign. So it's similar with this EQU variable expression rather. Okay, so this size now has a value of 0. So are we clear so far for the EQU? I think this is the easiest function that you guys could understand, since you're just simply equating or giving a value of of a certain variable. So are we clear so far up to this number 10? Or we proceed to the data item attributes. Some questions or clarification? All right, so it seems that there is no more questions. We still have 1 minute and 20 seconds. So let's try to finish this data item attributes. So we have 3 attributes. We have the type, the length, and then the size. So for the type, we have this one. See, this is the type 1, wherein it's the bytes. Type 2 is a word, and then type 3 is double word, or we even have the type 4 and type 5. Type 4 is the quad word. Okay, and then type 5 is also a quad word, but this one is the DB, the one that has or that can store 8 bit. Okay, so all in all, we have 5 types of attributes. Okay, so I hope we're clear with this one. And then length is the total number of building blocks that make up the data item. So we'll explain this one furthermore with these examples. And then size is number of bytes reserved for the data item. So correction regarding with this one, 200 words is not equal to 500, but 200 words is equal to 400 bytes only. Because again, it's 1:2. Okay, 200 words is just 400. Okay. So just change this 1 into 400. So we have some examples right here. So variable temp, double word, 200, duplicate, and then you don't know what is the value yet. Okay. So the type of this one is double word, not double word, defined word. My bad. I apologize regarding with that one. So this is the all right. So I guess we can continue now our discussion. So we're almost done. Okay. So you guys ready now? Just give me a quick thumbs up. Just let me know that you guys are now ready. So 3 out of 7, 4 out of 7. All right, so let's going back to our first example. Okay, so we have here temp TW 200 and duplicate. So let's just answer this one. How many or what is the type? What is the length, and then what is the size of this first example? So this is type 2 since this one is a word, a defined word, and then this has a length of 200. Okay, because it has, let's see, individual 200 individual characters or 200 individual values. And then this one has the size of 400 in byte. Okay, you stated that this size is or must be always in bytes. So if this is double word, okay, then this is a double word. If this is word, okay, rather define word, then 200 bytes, I don't know, 200 words is equal to 400 bytes. Okay. And then the next one is now in dB. Okay, so uh, zeros dB. So dB is type 1, okay, or byte is type 1. And then this one has a length of 50, okay, and the size of 50 also since it's already in byte. Okay, you don't need to multiply or convert this one anymore. Okay, and the last one is also dB. Okay, so in here we now have a more specific value, okay, of byte. So we have 35 each, 0f each, and then 60 each. So this one is also type 1 since this is again byte, okay, and then a length of 3 because we have 3 individual values, and then a size of 3. Okay, since this one is already byte. So 1 byte, 1 byte, 1 byte. So are we clear regarding with these examples right here? So I do have a question. What if these are zeros dB? Zero. So what is the type of this one? Call Miss Paklaw na. What type is this statement or expression? Is it type 1, type 2, type 3, type 4, type 5? We have dB. Yes, we have dB. Wait a second. dB, dW, dB. Ano ba? Meron naman. So what is type? What is a type or kind of type? Is that correct? Or what type, okay, of attributes? This is give an example. Ano yata siya? What about Mr. Maaba?
Type 3 ba?
Type 3, what about the length?
The length is 50. Yes. Wait. Sir, the length is 50.
The length is 50. What about the size?
Sir, 50 din po.
Ka dyan. So just base it on double word. Okay, if it's times 2, okay, then in double word, just base it on word only. If you only have word here as an example, okay, one word is 2 byte, while in double word is one double word is 4 byte. So this one should be times 4. So 50 times 50 is now equal to 200. Okay. If this is okay, next DQ, what word here? Quad word is equal to ilan na to? 80 bit. Para by 8 is 10, 8, 16, 24, 32. I'm just gonna come up. Wait a second. 16. 64 divided by 16 is 4 for double word. While this one, ay, 64, my bad. It's divided by 8 only. Okay, so 32 bit. So 32 divided by 8 is equal to 4 byte. Kumaklik yung equal sign. Okay. So while the quad word is, of course, 8 byte now. So if it's DQ, then 50 times 8 is 400. Okay. If it's DT, wherein we have 80 bit, so 80 divided by 8 is 10. So it would be times 10 now. So if it's DT, then this would be 500. Okay. So are you guys getting now the idea of this item attributes? Okay. Well, if it's DP now, of course, the type now is 5. Okay. If it's DQ for quad word, is 1 is 4. Okay. So that's it for the data item attributes. Now, let's move on now to your lab number 1. Okay. So in here, just provide pseudocode instruction for the following. So in here, label is equal to variable. So storing a 32-bit number 456 898 A0H in a location with label store. Okay, so I'll give you guys a bonus. So the answer for this one, or who would like to answer this one? Mr. Ramos, would you like to answer number 1? Give as a bonus to your classmates. Or does anyone who wants to volunteer to answer number 1? So don't you guys worry. I will correct you right away once you says or said an incorrect answer. Miss Paklauna, would you like to try? Mr. Mina or Mr. Golek? Mr. Ariana, Mr. Maaba, Mr. Ferreras, Mr. Tanikada, anyone? Number 1.
Try lang, sir.
Say, go, go, go.
Store DD 4567889A0H. Ano ba yun, sir? DD, sir.
DB.
DD. As in dog din, sir.
456 789. Okay. So store DD. Why DD? Because we have a total of 8 characters and DD is 2. Yeah, this is actually correct. Okay. So as simple as that. Okay. So just do the number 2, 3, 4, 5, and then the letter B. Okay. And then the letter C. Okay. You can just simply do this one on Microsoft Word and then submit it as a file right here. Okay, which will be due on June 1. So you guys have a week from now. Okay, so this is the file upload. All right. So C is similar with with the one that we had a while ago. sizes, types, and then the length. For this one, we already have here, a sample answer. So just answer those questions, 1 to 5 for the letter B. So yeah, that's it for your lab number 1. And then here is like the summary. Okay. So segments are the same as blocks in higher language programming. And then the dot model, again, just use a symbol for this course. Okay, so we have this types of memory. We have tiny, we have small, medium, compact, large, and then huge. And then, their sizes. And then we have the dot code, which indicates the start of the code segment, which consists of instruction. And then we have the dot stack, which defines the program stack segment. So in here, again, just use 100 each. And then that data is starts the initialized data segment, consists of data defining directives or initialization. So segment and ends defines the program segment. So you can create a new segment if you want, as long as it has a corresponding ending function. So for example, this is the new segment name. Let's say new segment, and then whatever is inside of that one, so data code. Okay, as long as it will also end on this similar variable name or segment name, rather. New seg and then ends. Okay. So yeah, that's all for the module 2. So any question or clarification so far under this PDF? Questions? None, can you guys give me thumbs up? Parang daw convinced dito eh. Parang marami kayong katanungan. Let me know that, if you guys have a question, would be better if you guys will ask it now as early as possible. Well, anyway, so you guys only have one work to do this week, which is the lab number 1. Okay, so maybe you will try to finish up to lab number 3 before your midterm exam. Anyway, so that is all for now. You guys don't have a question anymore, then yeah. That's all for now. Let's just meet again next week. Happy touch, all of you. Take care.
Thank you, sir.
You guys may go now.